next and the final speaker. So Peter Lindberg, who is the co-founder of Remos Space Systems. Hi, Peter. Welcome to the webinar, and thank you very much for your precious time again. I think we keep on interacting quite a lot, and it's good to finally have you on the webinar as one of the prime speakers.
Yes, so yeah, thanks a lot for the introduction, Omkar. I will start right away.
Absolutely. I'll start. I'll give it the control to you for sharing the screen. Yeah.
Okay. Can you see my screen?
Yeah.
Okay, great. Yeah, so thanks a lot for having me for this webinar. So we're called Remos. We're based right on the Arctic Circle in the northern Sweden. So we were part of the European Commission Cassini program a couple of years ago, and we work entirely with ground communication for mainly new space satellite missions. So the problem that we are kind of trying to solve is that today we have realized that a complete ground segment requires multiple different software and hardware products to be used in junction to control your satellite mission. And this can be quite complex and expensive for new space companies, and quite difficult to integrate and automate. So for example, this is how it can look like today. If you're a SME or a university building a satellite, you need to have different solutions for all different components of your ground station, and you could solve this with some open source software, but it's quite limited and quite resource intensive, so to say. So the solution we've come up with at Remos is a complete solution that combines essentially everything you need to control your satellite mission into just one single software, which can be controlled from one unified API from your mission control software. So of course, this simplifies mission control operation, makes it much easier to integrate. We have a very low learning curve since everything is in the same software, or you can use the API. And I would say our biggest advantage is that we're compatible with almost all different satellites. So we don't have this kind of vendor lock-in problem. So if you're using Allen Space, IC Space, and Eurosat Space CCST modems on the satellite, we're compatible with almost all different types of satellite onboard transponders. So we have done around 20 installations in 10 countries around the world, so among around 4 space agencies, and in the MENA region we have 2 customers in the UAE. So it will be a bit technical, but the first part of the software is the modem part, which is like the heart of the software. So here we can see that we support almost all kind of modulation schemes, line codes, and frame formats, which are typically found in this smaller satellite mission. The data rate for TTSC is around 1 megabit per second, or 1 megabaud. We plan to soon have this at around 20 Mbps, so we support the full S-band spectrum. And in the future year, we will also push this as high as 500 megabaud in both DVB-S2 and CCSTS protocols as well. So the second part of the software is the tracking. So what we've done is to combine or to implement different antennas from the industry to be like plug-and-play solution with our tracking software. So if you would already have a ground station with from one of these manufacturers, then our software can control this antenna system already, so to say. And then the same thing goes for the scheduler. So we have a built-in orbital propagator, and the first thing you kind of do is to put the coordinates of the ground station in your software. Then you can search which satellites you want to track, and then these will pop up in the path scheduler, and you can book a slot through the API or the path scheduler, and then once the satellite move over your ground station, it will upload or download any data that you command it to do from the mission control software. Then of course we have the sequencer part. So this is a hardware part if you go for the whole antenna system. So this is also controlled entirely from our software, so to say. Then we have a lot of diagnostic tools in the software. So we have a built-in spectrum analyzer, which shows the FFT, the waterfall, constellation, and distribution. We also have a built-in TMTC simulator, so you can do this kind of loopback testing when you're lab testing your satellite or measuring different parts of the RF chain. we have a lot of mission logs. So whenever you download data, you will get a lot of metadata where the antenna was pointing, the distance to the satellite, and a lot of things that you can run analytics on, specifically for this spatial situation awareness, pointing this to different places in the sky. And then, of course, you can also receive the data live in the software as well. So for API, we use TCP/IP sockets that are always open, so you can receive the telemetry, forward the telecommand. You can compare the antenna angles and Doppler compensation, or if you want to feed this externally, you can do that as well. And you can also record the raw IQ data from any pass and store it wherever you want as well. And then we use the RESTful API for controlling of all the settings in the software. So basically, how we offer our solutions is either perpetual modem. So this is very similar to the Cortex CRT. Then you get like a 4U server with a built-in digitizer on the back, and you get our software already built in and shipped to you. Or we can do this together with a ground station, and then you can get a ground station in basically any band. So we support VHF, UHF, S-band, L-band, and S and X-band. And then if you would already have all your infrastructure, for example, if you're a ground station as a service provider, then you could get just the software license, and you will pay for this, the modem, and then you would need to have a server. You would need to have a digitizer, for example, a DeFi digitizer or a USRP or any other digitizer that we support. And the a bit unique part with our software is that we run entirely on CPU. So we don't use GPU or we don't use FPGA. So you can run this in Amazon or Microsoft Azure, or basically you could even run this software in a small laptop if we're not talking about high data rates. And for the new space offerings, we have like this kind of turnkey solutions where you can either go for the UHF, VHF, and S-band solution, where you get the whole system, which is entirely controlled from our software, plug and play, start tracking satellites and downloading data within hours of putting this ground station up. And we also have a slightly more high-end solution for the S, X, and Ka band for this as well, where we give you a 3.7 meter dish and together with our modem, and where we will soon have the high data rate capabilities for DVB-S2 reception as well. And we also have this site available for hosting any kind of third-party ground station or GSAS antennas as well. We also have a web app for controlling, much easier to control from an operator view, either one or a network of our solutions. So we're not a mission control software developer, but we have done this for controlling kind of our own or a network of our own softwares, so to say. Yeah, so that was my very quick presentation. Thank you.
Thank you very much, Petter, for the wonderful presentation.